Hello there, I am Jan Graziani, a developer advocate at Teradata. Today I will perform multi-touch attribution. Multi-touch attribution is a powerful marketing technique that enables us to measure and credit touch points within customers' journeys that led to conversions. The goal is to identify the most performing channels so that future marketing resources and strategies can be allocated appropriately to acquire new customers. To perform this analysis, we're going to be using ClearScape Analytics Experience, an online site that lets us explore Teradata Vantage's AI/ML and analytic engine. Let's get started. To access our multi-touch attribution demo and many others, visit teradata.com/experience, where you can easily create a free environment and sign in. Within this interface, you'll be able to create Teradata Vantage environments, where you can ingest data, transform data, apply over 150 in-database functions against your data, build and maintain models using ModelOps. For this demonstration, we're going to select Run Demos. This will open up a hosted Jupyter environment on a separate tab, giving you access to over 90 AI/ML use cases across different industries, and they all include business scenarios, step-by-step instructions, sample data, and code. For this demonstration, we're going to filter by retail industry, and we're going to search for our multi-touch attribution for business analyst demo. We're going to select the Python SQL version. Businesses can employ a variety of models to perform multi-touch attribution, including rule-based models and statistical and machine learning-based models. Rule-based models require predetermined rules to assign credit along the customer journey. And in this demonstration, we're going to cover 4 of these rule-based models, including the first touch, last touch, even, and time decay rule-based models. The first touch rule-based model assigns all credit to the first touch point along the customer journey to conversions. Now, the last touch will assign all credit to the touch point before the conversion. Our even rule-based model will evenly distribute credit along the customer journey, and our time decay or exponential rule-based model will assign credit to the touch points closer to the conversion. For our statistical and machine learning-based models, those use advanced statistical and machine learning techniques to assign credit to each touch point. They consider additional factors like the order, timing, and the patterns of the touch points. I will briefly pause here to note that each approach has its strengths and limitations. For example, rule-based models may be easy to implement and understand. However, they may oversimplify customer journeys. On the other hand, our algorithmic-based models may offer more granular insights, but they will require advanced analytics expertise and extensive data sets. It's important for businesses to select the appropriate modeling technique based on their business goals, available data, and resources. Now, let's get back to our demonstration, where I will show you how you can begin building attribution models using Teradata's proprietary functions, including nPath, attribution, and association functions. Let's get back to it. Let's begin by importing the libraries that we need, including our Teradata ML library, which will allow us to operate and analyze our data on Teradata Vantage's massively parallel architecture. We then establish our connection to our database using the user and password we set at the start of this demonstration. And now we're ready to ingest data into our Teradata Vantage environment using a getData stored procedure. We call this getData function, which will be calling a native object store operation behind the scenes to ingest data from Google Cloud into our environment. Once our data has been ingested, we can take a moment to understand the data set we're working with. We have a digital marketing data set with around 575,000 records or rows and 7 different data points. If we preview our data frame, we can see that we have a column for cookie, our anonymous customer ID that allows us to track the progression of any given customer, our timestamp with date and time for any specific interaction, a column for conversions, a conversion value column, and an approximate cost column. Our final column is our channel column that indicates the marketing channel that brought the customer to our site. Once we understand our attribution data set we're working with, we can begin aggregating to create a data frame that will allow us to identify more information about the channels. Here we begin filtering by conversion. We drop our cookie column as well as our interaction column and group by channel to create our conversions data frame. This Teradata ML data frame makes it very simple for us to connect to third-party tools like Tableau or Power BI, enabling us to pass this data on to our business teams. We can also quickly perform visualizations within this Jupyter Notebook using our Python modules like Plotly and Seaborn. Here we can see that Facebook is our channel with the most conversions, and online display is the channel with the least conversions. We can perform additional analysis to identify the cost per channel, and we plot our data to quickly identify that the online video channel is the most expensive, followed by our paid search channel. We want to understand how our customers are converting. We want to understand the most common paths leading to conversions. To do this, we are going to use Teradata's nPath function. Here we're going to use nPath against our attribution data frame. We're going to partition by cookie and order by timestamp. We're going to select the non-overlapping mode, and we're going to have our nPath function output the paths with at least 8 events leading to conversions. Our result is stored in this Teradata ML data frame, which will make it very simple for us to use a Sankey diagram and visualize the top 100 paths. And the resulting data frame gives us the paths that lead to conversions, as well as a column with account for the events within each path and the cookie or user ID for each path that had a conversion. We can use the output and plot a Sankey diagram. We're going to plot the top 100 paths leading to conversions. And here we have our Sankey diagram showing the top 100 paths leading to conversions. If we hover our mouse pointer over any of the paths, we can see additional details. For example, the largest node here shows that there were 2,300 touch points on Facebook before the next event, which is conversion. We can use nPath not only to identify the most common paths leading to an event, such as conversions, but also to prepare data for more advanced statistical and machine learning techniques. In this demonstration, I will focus on creating rule-based attribution models. For the complete demonstration, to understand how to use nPath for data preparation, please visit ClearScape Analytics Experience. Now, let's continue to building our rule-based attribution models. We create one model for each type of rule-based attribution: uniform, first click, last click, and exponential. To easily execute all 4 rule-based models, we will leverage Teradata Vantage's native attribution function. This function will output a score or attribution weight and compute the time to conversion for all models, allowing us to derive additional insights. The attribution function requires input tables that contain the data for computing attributions. And our conversion event table, this table defines the conversion event, and a first model table. This table defines the type and distribution of the model. Since we have 4 rule-based models, we will create 4 separate tables, one for each model. We create our conversion event table. Because we are focusing on events that led to conversions, our attribution conversions table will only have one value: conversions. We then create our model specification tables. We need to create one model table for each type of attribution. And each model table will include 2 columns, a column for ID and model. And we will also define the specifications for each table. We'll begin with our uniform model. Our uniform model is going to assign credit evenly across all customer touchpoints. Our first click model will apply 100% of the credit to the first click in the user's journey. And our last click model will apply 100% of the credit to the last interaction in the customer journey. our exponential model will assign more weight exponentially to the interactions which are closest in time to conversion. Now that we have built our 4 model specification tables, we are ready to perform the computation using our attribution function and store our outputs in a table. We load our data frames from our recently created tables, and we apply our attribution function against our 4 model specification data frames to compute our model attributions and retrieve our results. We then consolidate our results into one data frame. And here we have the resulting data frame where each row represents a different customer interaction, and the columns include the credit that each attribution model assigns to each touch point. We also have the total time to conversion metrics. Once we have our consolidated data frame, we can then calculate attribution weights by channel and rule-based models. And here we have the total attributions for each channel, including our exponential, first click, last click, and uniform. Using Plotly, we can now confidently compare our channel performance. Here we see that Facebook receives the highest attribution values across all models, while online display receives the lowest attribution values across all models. Thank you so much for watching. I have demonstrated how to use Teradata's native attribution function to efficiently compute 4 rule-based attribution models, which enable us to measure and visualize marketing channel performance. I invite you to complete the rest of this demonstration and compare these results with machine learning and statistical models on Teradata Vantage. Visit teradata.com/experience, sign in, and search for the MultiTouch Attribution demonstration. Thank you so much for watching. Until next time.